This podcast is brought to you by a-eon.biz, stickerrobot.com, the minotaurproject.co.uk, and pvpubs.com. Hello, my name's Adam Spring, and this is a Remotely Interested podcast, hosted at remotely-interested.com. My guest for this episode is Tim Urbaniak. Tim is soon to be a retired professor from Montana State University Billings. By the time you're listening to this, he probably is retired. And he was also a draftsman in his former life. He crossed over from the construction industry into academia, and along the way, he actually got himself a PhD as well from the University of Montana in Missoula. And that PhD was in one of the passions he found later in life, which is cultural heritage. Now, Tim has worked with a variety of technologies over the years, going from pen and paper to things like laser scanners and anything dealing with as-built information, so point cloud-based design. He is also a really interesting guy in the sense that he's never afraid to think and live outside of the box. For example, we talk about a building that he's built in the middle of Montana somewhere, in an undisclosed location. Anyway, I will leave you with Tim for now, and I will talk to you again at the end of the show. So, thanks a lot. So, tell me a little bit more about what you do at the moment and how you kind of got to where you are.
Well, at the moment, I'm finishing up my teaching career at Montana State University in Billings. I've been teaching in the drafting and design program, the primary focus of which is a 2-year Associate of Applied Science. But I've been teaching in the drafting and design program for 29 years. So I came into drafting and design 10 years prior to that from industry. And when I first came out of school for drafting, I went into industrial structural and worked in industrial structural for around 10 years. I tell my students that I was working in drafting and design BC, if you consider that before computers. And of course, the older you get, you know, the worse the war stories are. But I think it really is difficult to convey the impact of what it was like to work in basically a mathematical, graphical-driven industry before we had calculators, let alone programmable calculators, let alone desktop computers, and all of that came about. When I came out, actually a little bit before I came out of industry, in the early 80s, began looking at some computer applications. I started with some of that by programming for Hewlett-Packard handheld calculators to solve structural problems. We wrote code that would ask a sequence of questions and then give us dimensions on stairways and give us dimensions on X-bracing and things of that type. Started programming, I guess my first CAD was programming in BASIC, just so that we could output some simple shapes on a dot matrix printer. We were shopping for some sort of a higher-end CAD station when AutoCAD came out, and so I stepped into the world of AutoCAD with the first release that was available to the public. About 2 years after that, in the late 80s, 88 I believe, they were closing the structural steel company, and as I was looking for jobs, the job came up at what was then the Billings Votech in Billings, Montana, teaching in a drafting certificate program. And so I went to there to take care of the CAD part of it, and even early in the software, I became interested in customization and list programming and taught AutoList for years. But went to work in the program, and as time went on, the Votech left the school district and came under the Board of Regents in Montana, and then eventually we merged with the local college and became a university. And so I have progressed all the way through the first AutoCAD systems working in the DOS environment on what we certainly would consider very minimal machines, to all of the technologies that we're embracing today, three-dimensional, small, mid-range, long-range scanning, tripod-mounted LiDAR, the photogrammetry, multimedia, global positioning systems, GIS. I mean, throw a technology out there that has to do with gathering or recording information and assimilating that, and I've probably touched most, if not all of them. Along with software experience, of course, we still use, AutoCAD, but I've dealt with a variety of architectural software and civil software and the Adobe suite and, structural SDS2, SolidWorks, Inventor, a slurry of software. It would take quite some time to explain all the software that I've interacted with over the years.
So in terms of your foundation in the technologies you work with now, what did draftsmen do before computers? What was the workflow?
Well, the drafting workflow before computers, of course, at the earliest stage that I was in, pencils, straight edges, angular measurements with the assistance of, we went fairly soon from T-squares to what we call drafting machines, where, you had a head that would help you turn angles. Hand-done calculations supported by a lot of books. You didn't have to hand calc out the cosine if you had a book where you could look up the cosine of that angle and so on. And that helped us, do, I guess, what I'd call manual mathematics. There was a book that we used to rely on quite heavily, which I actually still have on my shelf here, called the Smoley's Slopes and Rises. It's a book that has a lot of triangular information, and so if you wanted to know the hypotenuse of a triangle, it's 12 foot by 15 foot on a right triangle. You can go there and you can look it up. Of course, if it's 12 foot 2 1/16, you've got to do a little more work. But again, a lot of reference tables. Pencils put down by lead, things that are now pretty much gone in the industry. People might forget that with the old lead pointers, as you moved your pencil down a straight edge, you had to spin the pencil so that you would get a nice, even, straight line. And old drafting sayings that people have forgotten, things like never draw more in a morning than you can erase in an afternoon.
So in terms of the technologies you work with now, what sort of applications are you using things like laser scanners or anything point cloud based for?
Well, jumping ahead to point clouds, actually, even before point clouds, we were using a technique with a prismless total station in an architectural environment. As a surveying instrument, of course, but we started using a technique where we would set the total station up and then having to take one point at a time. If we were working on, for instance, an architectural restoration project or a documentation stabilization project on an old building, we would shoot points with the total station that were like the corners of the windows, the corners of the window trim, the peak of the roof, and then we would do that from a couple of different angles, and then we would point match those together just to get some general dimensioning, kind of a three-dimensional connect the dots. Now, of course, when the 3D scanner technologies came along, of course, you get millions of those points. You get the point cloud, as it were, and so instead of getting things slowly one at a time, you get a lot of information in a relatively short time. And so the workflow on a building, for instance, is to go out and scan that building, take your scans, merge them together, bring that into, do whatever cloud editing you need to do, and then bring that into the CAD environment and model over the top of that. And so that is a workflow that we have used many, many times.
So it seems as though in terms of this leap from manually doing it to, semi-manually doing it to fully digitizing the process, the difference in the way in which you're interpreting the as-built information has become insanely, you've now got more information to deal with as opposed to previously, whereby I imagine, drafting would have been a very timely process.
Well, there are still considerations for the information. I mean, if you went out to a building in the old days with a ladder and a tape measure and you measured the wall and said, this is how wide the building is. It's 20 foot 6 inches wide. Well, you wrote that in your notes, and that, by golly, was what it was. When you go out with a point cloud, there are times when you almost get too much information, because you find that buildings are not maybe quite as square as you thought they were. That there might be a little bit of a lean in it if you're dealing with a piping manifold. Things might not be quite where you thought they were. And so you find yourself sometimes making decisions even within that point cloud. Because the CAD software, for instance, the architectural Autodesk's Revit, it wants square corners. Not to say that you can't create a radial wall with it or a wall at a slope, but it doesn't like that out of the box. It expects walls to be straight and true, and not all buildings are as straight and true as they thought they were, particularly historic buildings. So within the point cloud, as you're modeling, you have to make decisions as to how you're going to represent that.
So essentially the interpretation process has changed. There's still an element of interpretation there, but it's not necessarily as obvious as it was previously. It's down to the experience of the user.
It has. Interpreting that information has changed. The modifying workflow is something that really has become big in drafting and design. The way we did it 20, 30 years ago is certainly, not the way we approach projects now, especially through these object-oriented software, where you create a 3D model, basically, of what it is that you are drawing, and then you extract your working drawings from that model. Or to have everything in one package, not having, drawings behaving independently of each other. And I've seen a lot of modifications to the workflow. I think we have more modifications to the workflow coming. It's always interested me how people involved in drafting and design, and consequently mechanical, architectural, engineering, have resisted changes in workflow. When CAD first came in, it's interesting, but it's not something our company will ever use. Well, you heard that from some folks. Now, of course, we're past that. Same with 3D. When 3D came in, well, 3D is interesting, but it's not something our company would use. Well, that may have held true for a while, and certainly there are still people not embracing 3D, but it's becoming more and more difficult to not do that. And so as things like the point clouds and the scanners come in, there are still companies that are looking at that and saying, that looks like an interesting technology, but we don't really have a use for it. And yet people are contacting me and saying, okay, we're getting ready to start our first project that involves a 3D point cloud. What should we be looking for? What do we need to know? In some cases, entities like architectural firms, if they've not touched it, then they're going to use a contractor to 3D scan a building that they're maybe going to remodel. They really maybe don't even know what to ask for in their specifications. What file types are going to come out? Will they be able to use them? And then I've been on the side of this as a contractor, where then you give that data to your client, and the client really doesn't know what to do with it. It's an interesting part of that, but it's the way we're heading. So companies need to jump in sooner than later.
Yeah, and I think it's certainly interesting talking about the application in the part of the world that you're in, because it's quite interesting from a British perspective. And I've seen this very much at the Intermountain GIS conference that I attended, where, you and I talked, is in the US, the periphery is very much seen in the middle, whereas having come from the UK, which, obviously by the accent I clearly am, it's always on the outskirts, so on the coastlines, so Cornwall's, Wales, Scotland's of this world and things like that. Now, in terms of laser scanning stroke point cloud applications in the Pacific Northwest and, the Montana, Wyoming, South Dakota, North Dakota sort of areas, what are the sort of applications going on for the point cloud, 3D scanning, photogrammetry, stuff like that?
Well, there is, again, certainly more of this coming in. We now have A year ago, I think we had maybe, let me go back a little further. Maybe 2-3 years ago, we had no scanners in town, and then we had one, and now we have two, and I've heard of two more within 100 miles recently. So the first places that really embraced them in this region was the mining industry. Mining industry has been working with 3D scanning for a while, and again, it's because they were, first of all, they maybe have a little more money to work with than a small architectural firm or a small engineering firm. But again, it comes back to payback and value. And when they can analyze volume, volume of overburden moved or volume of materials, when it's a much more efficient thing where they can see that it pays the bottom line, they were the first ones to get in. So the mining industry, whether it's surface coal, we do have some subsurface mining that goes on here. And that was actually the first 3D scanner that I ever saw was at Platinum Palladium mine that is not too far from here. So mining went in first. I would say really that probably civil was second, and I would say civil in the mechanical sense. Some things about bridges and refineries where you have these piping manifolds. Point clouds are an extremely accurate way to represent these piping manifolds. And again, I say that from the perspective of having crawled around in those with a notebook and a tape measure before, trying to make sense of a piping manifold, and then thinking that any pipe you draw or any run that you draw is actually going to fit through it when you're done. So again, they saw the value in that second, and now we see some architectural applications coming forward. We see some architectural firms that are just beginning to work with the point clouds and want to know how to do that. So mining first and then civil, and now architectural firms are beginning to embrace it.
Yeah, and I think it's interesting because one of the things that I'm constantly thinking about through this conversation is the example that you did in Red Lodge, where you didn't even use a scanner at all, but you actually used old mine maps. I actually think that's an incredible example of if you're going to do 3D, it's understanding what you need to do it and how you do it, So I find that very interesting.
Well, and the Red Lodge mining, to recreate the mine tunnels from the old mining maps. That was a very interesting project. And we did use the 3D scanner on that, but not underground. The only thing we used it for is there's a part in town where the side of the hillside is still visible. The strata is still visible. And so as we were working from the maps, putting the strata and the slope into these mine tunnels, we scanned the geology there, and then we were able to take the angle from that geology and compare it to what the maps were telling us, and it was actually a slope map. The surface strata slope was the same slope as how they were doing their mining tunnels, so it follows underground.
And how did you get into the heritage applications for digital technologies?
Well, for heritage applications, again, as I was teaching, again, we started as a VOTEC, which was a non-credit granting institution, et cetera. Post-secondary, after high school, career education. But it wasn't a college, it wasn't a university, and so I was able to teach with a provisional teaching certificate, even though I did not at that time even have a 4-year degree, let alone 2-year degree. After we went to the Board of Regents for the governance of our institution, and then later merged with the other campus and became MSU Billings, a university. Well, there's an expectation for faculty in that environment. Are you writing? Are you researching? And if so, what? And how are you disseminating that to the public and building your community and the body of knowledge out there? And so, faculty began to look at that, and I looked at it. I had been in industry. I had a company at that point in time that that was doing structural steel detailing. I've joked that I had a company that did steel detailing so that I could afford to stay teaching, because of course it's not nearly the salary as industry. And so I had done the commercial industrial thing, and I didn't need to draw a building for someone. I had done that, and I was interested in the technology. Where can we apply this? And so at about the same time, the university came out with an initiative to kind of have us work interdisciplinary between the campuses and to do something that was unique to the region and and would connect us with, other entities, the greater community at large. And so I had been interested in archaeology for quite some time through a very good friend of mine, Oren Koenig, had gotten me interested in archaeology. And so we came up with a plan that maybe we could do a project to use digital cameras to document rock art in the region, Native American pictographs and petroglyphs. And so that was actually our first project, as we obtained one of the first digital cameras that was in Montana and started documenting this material with a camera whose resolution we would consider abhorrent right now. But nevertheless, I got into that, and the further I went, the further I came to believe in what I refer to as synthesis across disciplines, that these tools weren't being embraced by everyone that could be using them. In particular, archaeologists at the time were not, they weren't into, we had CAD, that was an old-time thing, but they weren't embracing that. We're talking about a time when PowerPoint became a new thing. It hadn't been there before. And so I started crossing those projects because I was interested in it. And so how can I apply these technologies, and how can I help other people apply these technologies? First of all, in the classroom, as being relevant to drafting and design. Why would a contractor need this? Why would an architect need this? Why would this be necessary on a road construction project? But then to take that into this other field where my personal research resided, and say, all right, how can I apply this tool to archaeology, to history, to anthropology? And so we created an entity at that time, actually 20 years ago this spring. We created the MSU Billings Archaeology Field Team. And the mission of the field team became to assist archaeologists and historians in their research through applications of technology. And so that opened the floodgate. Any technology you can think of, GPS. There was a time when GPS was new. Well, what's that work? And again, how does that apply in our drafting and technology program as to mapping and how this is evolving in the surveying world? But then again, for an interesting project, what can we go out and do with that? Well, here's a project on mapping battlefield casings and bullets. That use it for one function. Use it for laying out a subdivision, or go map a battlefield. Architectural software. Yep, in the drafting and design world, this is how they're designing buildings. This is how that applies. This is what you'll be hired for. In my research, to take that over, and if I was going to draw a 3D building, I would model a fort that doesn't exist anymore. Maybe they had excavated the footings on it. Well, from that and getting those measurements, we could recreate the building. So as we cascaded through all of these technologies and they came out, the GIS mapping, how can we apply that? Well, we can take old historic maps that the military was making, and we can overlay those in GIS, and now we can go out and find where those sites are again. And that's a technique that works fairly well. So that brought me into, as this went on, my interest kept going. I kept attending more degrees. I did a bachelor degree, a master degree. Eventually found myself in a doctorate in anthropology, which I've since completed. But again, every time I would look at some of these functions and look at a grant, it could really go two ways. I could get the grant for my heritage research, but I could also tie that grant to making it applicable to drafting and design in the classroom and bridge those worlds together. And the more I did that with my research, the more I was able to carry that into the greater community so that our regional archaeologists, we could, it seems like for some time at the Montana Archaeological Society, it was like whenever I would present, it would be a new technology we're using and something new. And so I kind of, I rode that wave. Oh, here's something new. And sometimes people would joke, it's like, geez, what next? A time machine? Is that it? And I've not seen them in Amazon yet, but, we're reaching a point where, you have to really look ahead to see what new technologies are going to come out there. And again, how to embrace them and how, once you have that technology, that it applies not to just a narrowband field, but how a variety of entities can synthesize that across what they do.
Yeah, I describe that as not being afraid to look over the fence and see what your neighbor is doing. That's how I like to describe that one.
Yep.
Yeah, and it's interesting.
And again, to not stay there. One thing that I really personally enjoy, that I would say it's a quirk, but I've probably got a catalog of quirks that I have. I love going into an environment where there is someone working in that environment where I know absolutely nothing about what they're doing, and looking at their tools. Like even if it's not a technology tool, to go into a shop, a glazer's shop where they're working with all the glass. What do they use? What do they got? What do they got in their toolbox that if I looked at it, I would have no idea what that is? But yet, if you figure it out, you might figure out another use for it. And I just find that fascinating.
Yeah, I agree with you. And I think it's interesting because I think we're at a point where, everybody's hambling to be the expert in the room, but really the smartest person in the room is the one that doesn't know they're the expert. Do you know what I mean? Never be afraid to ask questions or look at things from a completely different angle.
Right. And in archaeology, I think you can take it to a such a base level as, if you have a shaker screen that you've been using for some time, and you take somebody who is primarily a carpenter or a woodworker, and you put them on that screen for a while, it's not going to take too many hours before they're probably going to come back and say, you know what? If we just did this right here, it would be a lot better.
Yeah, and it's interesting as well, sort of talking to you about stuff, because one thing that's really coming across from the beginning of our conversation to now is it seems as though the transition from paper to somewhat paperless is something that's influenced and impacted your career a lot. But at the same time, it also sounds as though that coming from, for want of a better word, an applied discipline has also really informed your thought processes as well. Would you agree with that statement?
Yeah. Paperless, of course, we're still not quite paperless. I don't know as we'll ever be. I heard, I don't know if that's appropriate or not, but I heard years ago someone say that we're going to have a paperless office about the same time as we have a paperless toilet. It's still necessary, but to not nearly the same extent. I still have paper maps here, even though I have them all as digital as well. But they certainly don't get used much. The problem after paperless is data organization and management, and I've considered that for quite some time. In an academic environment, especially with heritage resources or cultural resources, however you want to look at that, you don't want everyone to get the data. Even back to digital imaging, the first time we showed rock art researchers that we could modify a photo of the rock art, that just sent shockwaves to some people that why would you do such a horrible thing? Now D-Stretch is a common tool. Everybody does it. The important thing is to, say when you do that and explain that up front. But not all of those sites are public. So when you photograph this material, when you take the GPS location, people were concerned then, and they still are concerned about what's going to happen to that information. And once it's released to the web in the world, well, it's really tough to spool that back in. So first of all, after 20 years of working on projects of that type, I've got USB drives lined up and backed up, and I'm not sure how many terabytes sitting I have right now, but it's quite a bit of information. So you have to make sure you do your backups. You have to make sure that your data can migrate. If everything you have is in a WordStar format for a document from 20 years ago, well, something has to change because we don't have that anymore. These point clouds, that's a question into the future. And something I advocate is if you're storing a point cloud, particularly if you're using something like Cyclone, don't just store it in the native file type. Export that. Export it as an XYZ, a PTS, whatever format makes you happy, but get it out there in a variety of formats when you archive it, because later some of the software we're using might not be around.
Yeah, and the analogy I'll use for that, because I know you're a Batman fan, and I'll tie in a pop culture one, is there's an episode of one of the Batman cartoons whereby Dr. Freeze manages to cryogenically freeze himself sort of 2,000 years in the future, and there's archaeologists actually walking into the Batcave, and they suddenly notice there's all this stuff on the walls, and they're like, what is this? They scan it, and it turns out it's actually a physical computer program, because Batman knew that digital was never going to last, and that's how they managed to defeat him. So I managed to tie in Batman for you because I know you like him.
Nice. That is nice. I will admit that I have done this with my own construction. I've done some unusual personal construction. Occasionally, I not only empty my pockets, but I take other things there to throw into the concrete, so that later, should someone find that, here's a half a gig USB drive. Oh, here's a 386 computer chip, and I think I'll throw that in there with an old 3.5 inch floppy drive. Yep, we'll just put that up in the block right there. That'll be good.
Well, I think also as well, it may be useful for the audience to know that you've actually built your own property out of, would you call it junk or unused goods, out in the middle of Montana as well, which is very impressive.
Our vacation cabin, if you will, is made out of a lot of recycled material, recycled windows. A lot of the joists are mobile home, trailer house frames, and things like that. Pipe that had been used at coal strip that came out of service and is now handrail and things of that type. So, yep, I have an interest in reusing old things.
But I think to paint a picture as well, this property is literally totally off the grid. It runs off a 12-volt battery, is it?
A bank of 12-volt batteries in a solar array.
And the back of the actual building stroke the wall is actually the side of a rock face. So the rock face is actually part of the building itself. It's pretty cool. So Tim, great interview. Really appreciate it. And so where are you moving next? You're near retirement. You're thinking about what you're going to do next. You're clearly somebody that's never going to retire. What have you got lined up next?
I've got a couple of different books that I've just in the outlining stages of. I've got a lot more researching and publishing that I want to do. My anthropology work turned to historic inscriptions on the Northern Plains. The names, dates, pictures, things that came following the rock art, following the contact era. I'm still doing rock art research, and I see communication ties between those fields. But I've successfully completed my paperwork for the state of Montana, and have created a sole owner corporation called True Technologies. True is TRU, which are my initials, so it's True Technologies. And I have a lot of equipment of my own as I leave the university. So I have my own 3D printer and my own cameras and so on and so forth that I'm able to work with. Considering buying a tripod-mounted LiDAR. I've got a couple months left before I'll ultimately make that decision, but I'm really considering buying a used one of those. And I'm looking at doing, getting into the cultural resource management world a little bit and working with some of the agencies a little more, and focusing more on the cultural heritage preservation and less on the commercial drafting and design world. I have told people that I used to be a capitalist. Now I consider myself idealist, I guess. Used to be a capitalist. Now I think I'm more of an idealist. I'm willing to do great amounts of work for not much money just because I believe in the project.
So as Tim prepared to move on to the next phase of his career, I thought it was interesting to see where he was thinking about going next. Certainly in terms of his commercial work and his work with cultural heritage, I think someone of his skill sets and also someone of his varied knowledge base is going to do very well, particularly in a part of the world which, interesting enough from a UK perspective, in America, as I said in the interview, the periphery kind of is in the middle, which for me, having come from a place like Cornwall, which is perceived as a periphery in the UK, an island, we're on the coast and stuff like that. It's going to be interesting to keep an eye on Tim and see what sort of case studies and stuff that he works on in a very interesting part of the world, particularly in terms of inscribed surfaces over a very large area and their positioning on the landscape. Anyway, that's me for now, and I'll speak to you next time. Hello there, my name's Adam Spring, and I'm here to talk to you about a number of ways in which you can stay connected with and contribute to the Remotely Interested podcast. As I've said before, it's listener supported, and I love to include you guys as much as I can. Anyway, the big two are iTunes and SoundCloud, which you can subscribe to. Also for SoundCloud, you can follow, you can like, you can share, you can do a number of things with the content that I put up there. There's also Google Play where you can check this podcast out, and there's also a Facebook page that you can like. Now, in terms of connecting with me directly, there's a Twitter handle, which is @thatinterested. You can also follow and reach out to me there. And there's also the Remotely Interested email as well, which is contact@remotely-interested.com. Anyway, I love doing this for you. I hope you enjoy it, and thanks for listening to the show.